Welcome to the DIY Honda Garage channel. The Diagnostic Trouble Code, DTC P0793, indicates an issue with the intermediate shaft speed sensor A circuit, specifically a no-signal condition. This code pertains to the continuously variable transmission, CVT, of the Honda Fit models produced from 2015 to 2020. The intermediate shaft speed sensor is a crucial component, as it monitors the speed of the shaft within the transmission and transmits this information to the Powertrain Control Module, PCM, ensuring optimal vehicle performance. The vehicle's transmission relies on accurate speed readings to adjust gear ratios effectively. In most instances, DTC P0793 is triggered due to electrical circuit issues, rather than any mechanical failures in the transmission itself. It is essential to follow a structured troubleshooting approach to identify the root cause of this issue. The DTC P0793 specifically highlights an electrical failure within the intermediate shaft speed sensor A circuit. The affected component is the CVT drive pulley speed sensor, located within the transmission assembly of the Honda Fit. This sensor is pivotal for monitoring the speed of the drive pulley, allowing the PCM to regulate transmission ratios smoothly and efficiently, thereby enhancing fuel economy and performance. Additionally, the presence of this DTC indicates that the system cannot receive a signal from the speed sensor, leading the PCM to potentially miscalculate the vehicle's performance metrics. This code should be addressed to prevent any degradation in vehicle functionality. Remember that mechanical issues within the transmission do not cause this code, as this is strictly an electrical fault. The primary causes of DTC P0793 predominantly focus on electrical circuit problems. One potential issue may be poor connections between the CVT drive pulley speed sensor and the PCM, which can result in intermittent signal loss. Another common cause is loose terminals in the circuit that may prevent a proper connection. These electrical faults can create erratic behavior in the transmission system, causing miscommunication between the sensor and the PCM. Although these issues must be investigated closely, it is crucial to remember that they do not stem from any mechanical components within the transmission itself. Ensuring thorough checks of various connections can aid in pinpointing the exact source of the problem. Symptoms associated with DTC P0793 typically manifest as warning lights on the dashboard. The most immediate indication may include a check engine light illuminating. Additionally, drivers may experience performance issues, such as unexpected engine behavior, rough idling, or inconsistent speeds, particularly during acceleration or deceleration. These symptoms indicate that the vehicle's transmission may not be adapting effectively to driving conditions due to inaccurate readings from the speed sensor. Monitoring the vehicle's performance closely when this code is activated is essential to prevent further complications in drivability and efficiency. The first step in troubleshooting DTC P0793 involves confirming the existence of the code and attempting to clear it. Begin by turning the vehicle to the on mode without starting the engine. Once the vehicle is in this mode, use the Honda Diagnostic System, HDS, to clear any existing DTCs. This allows the vehicle's onboard computers to reset. After clearing the DTC, turn off the vehicle completely and ensure it is in the lock position. It is crucial to note that this is primarily a diagnostic procedure to verify whether the DTC reappears upon subsequent driving, helping to distinguish between a persistent and intermittent fault. In this troubleshooting step, the focus is on the electrical connection of the CVT drive pulley speed sensor. Start by ensuring the vehicle is turned to the off or lock mode before disconnecting the CVT drive pulley speed sensor's 3P connector. With the connector disconnected, switch the vehicle back to the on mode without starting the engine. Use a multimeter to measure the voltage between test points labeled 1 and 2. Test point 1 corresponds to pin number 1 of the CVT drive pulley speed sensor connector, while test point 2 is attached to the body's ground. You should expect a voltage measurement of approximately 5 volts. If this voltage is present, it indicates that the power supply to the sensor is functioning correctly. The third troubleshooting step involves checking the voltage common circuit 1, VCC1 line, ensuring that the electrical pathway connecting the CVT drive pulley speed sensor to the PCM is intact. Start by measuring the voltage again at test points 1 and 2 with the CVT drive pulley speed sensor's 3P connector still disconnected. Test point 1 should correspond to pin number 3 of the connector, and test point 2 to the body ground. The expectation is to find a voltage reading of approximately 5 volts. If this voltage is confirmed, it suggests that the VCC1 wire is functioning correctly. However, if the voltage is absent, it indicates an issue, likely due to an open circuit within the VCC1 wire between the sensor and the powertrain control module. In the fourth step of troubleshooting, the focus centers specifically on the CVT drive pulley speed sensor itself. With the 3P connector still disconnected, utilize a multimeter to measure the voltage between test points 1 and 2. Test point 1 will correspond to pin number 2 of the sensor connector, while test point 2 will correspond to pin number 3. At this point, you should be able to verify whether the expected voltage of approximately 5 volts is present at these terminals. If the voltage is confirmed as present, the sensor itself is deemed faulty, necessitating its replacement. Conversely, should the voltage not be present, this hints at an open circuit in the sensor ground 1, SG1 wire leading to the PCM, which also requires addressing. Step 5 deals with checking for shorted wires within the NDR-DD line connected to the CVT drive pulley speed sensor. Begin by ensuring the vehicle is turned to the off or lock mode, and then proceed to jump the SCS line using the HDS tool. Following this, disconnect the PCM connector C, which has 51 pins. Utilize your multimeter to measure continuity between the designated test points. Test point 1 refers to pin number 1 of the speed sensor connector, while test point 2 corresponds to the body ground. If continuity is detected here, it signifies that there is a short to ground in the NDR-DD wire, thereby necessitating repairs. If no continuity is present, this indicates that the NDR-DD wire has no shorting issues, allowing for further investigation. In the final troubleshooting step, the focus shifts back to ensuring the integrity of the NDR-DD line within the electrical circuit. This entails analyzing continuity using the multimeter between the indicated test points while the vehicle remains in the off or lock mode. The specific connections to examine are between pin number 1 of the CVT drive pulley speed sensor connector and pin number 21 of the PCM connector C, both of which should be disconnected during this testing. If continuity is confirmed, it indicates that the NDR-DD wire is functioning properly. Under these circumstances, it would be advisable to update the powertrain control module software if it is outdated, or alternatively, substitute it with a known good PCM. If the DTC clears following an update or replacement, troubleshooting is complete. However, if the DTC persists, open repairs within the NDR-DD wire should be addressed. After completing the troubleshooting steps for DTC P0793, it is imperative to perform final verification to ensure that repairs have been effective. Begin by meticulously verifying that all connections are secure, without any potential loose wires or corroded terminals. Once all connections are checked, proceed to test drive the vehicle under similar conditions that initially triggered the DTC. This vehicle should be driven at speeds exceeding 19 miles per hour for at least 30 seconds to replicate operational conditions. During and after this test drive, monitor the dashboard for any reappearance of the DTC. Successful verification will have resolved the DTC, affirming the efficacy of the repairs undertaken. To help prevent the occurrence of DTC P0793 in the future, implementing regular preventive maintenance procedures is crucial. Schedule periodic electrical inspections of the vehicle's wiring to identify any degrading connections or potential wear before they become problematic. Check the condition of connectors at both the CVT drive pulley speed sensor and the PCM, ensuring that terminals are clean and secure. Regularly verify the function of the intermediate shaft speed sensor, as issues here can lead to larger transmission complications. By staying on top of these maintenance checks, vehicle owners can minimize the risk of electrical faults within the transmission system. In conclusion, understanding DTC P0793, along with its implications on the Honda Fit's operability, is essential for maintaining vehicle performance. This code indicates a problem with the intermediate shaft speed sensor A circuit due to electrical issues rather than mechanical ones. Following the structured troubleshooting steps allows for thorough problem identification and resolution. By accurately diagnosing the root cause and addressing any faults within the system, drivers can prevent recurrence of similar issues. Furthermore, adhering to regular preventive maintenance practices can help sustain the integrity of the vehicle's transmission system and ensure reliable operation over time. Please like and subscribe to the channel. See you next time.